The energy sector is seeking new solutions to produce energy in a more sustainable way. Sustainable energy is driven by the needs to reduce greenhouse gas emissions, to secure the country's energy supply, and to meet the European Union and national targets of increasing the share of renewable energy in energy production. Bioenergy is a technically proven, economically feasible and environmentally sound alternative that provides a competitive solution in the liberated energy market. Finland is the world leader in developing and utilizing wood-based bioenergy technology. The expertise of Finnish companies covers the whole value chain, from the forest to the customers. Because of Finland's intensive forest industry, the main sources of wood fuels are the industry byproducts, such as black liquor, bark and sawdust. However, through advanced technologies, logging residues, small whole trees, stumps and roots are increasingly being used in modern power plants in the form of forest chips. Harvesting is the first step in the long logistical chain of green energy. With the bundling method, logging residues can be economically utilized in large-scale energy production. The main advantage of the bundling method is that it integrates industrial and energy wood logistics efficiently, as the bundles can be transported by standard timber trucks. Single operations in the fuel supply chain, such as harvesting, chipping, crushing and transportation, are often carried out by local entrepreneurs. They are contracted by the procurement organization and are part of its quality control system, since undisturbed fuel supply is essential to the smooth operation of a power plant. Homogeneous quality of forest chips, as well as reliable and timely deliveries, are the key elements in continuous fuel supply. Efficient transportation is crucial, as transportation costs are the largest cost item in the procurement chain. Full loads, good logistical planning and high technology-based navigation systems are critical for cost-efficient operation. Before combustion, the forest residues are comminuted, that is, chipped or crushed. The comminution can take place in terrain, at landing, at terminal or at plant. In case of comminution at plant, the logging residue bundles, as well as stumps and roots, are crushed with special equipment. The resulting wood chips are often mixed with other fuels, such as peat, especially in large-scale energy production, where wood-based biomass can seldom meet the total fuel demand in a cost-efficient way. In some Finnish power plants, up to 5 different fuels are combusted together. A typical example of large-scale combined heat and power generation is the Kokkola power plant that produces 20 megawatts of electricity and 50 megawatts of district heat for the city of Kokkola. The fuel mix of the power plant consists of logging residues, bark, sawdust and peat. The heart of the power plant is the bubbling fluidized bed combustion boiler, which allows fuel flexibility, high efficiency and low emissions. Wood fuels are also utilized for small-scale combined heat and power production. The cogeneration plant and the 9-megawatt thermal plant at the Vilppula sawmill produce over 70% of the sawmill's electricity need and 100% of the heat needed for drying the wood at the sawmill, as well as all the heat needed in the town of Vilppula. The electrical output of the cogeneration plant is 2.9 megawatts and the heat output is 13.5 megawatts. The cogeneration plant located in Forsa is an excellent example of how beneficial the integration of wood fuel supply chain and power production can be, both for the local economy and the environment. The Forssa power plant produces 17 megawatts of electricity and 48 megawatts of district heat for the town of Forssa and its neighbouring areas. The fuels combusted for energy generation are environmentally friendly, consisting mainly of industrial wood residues and forest chips. All energy production has environmental effects. Wood-based bioenergy production combines carbon-neutral renewable fuel resources with the cogeneration process that produces both electricity and heat with very high efficiency. Even the ash produced in the process can be utilized and recycled back to the forest as a fertilizer.